Hi everyone. So this is the research part of the chapter that we were going to cover this week, and I just wanted to make sure all of it was in this one video in case you missed any or if you have any questions about any of it. So the basic thing is that when we're talking about research in psychology, we want to know first, what is psychology? Why do we do it? When do we do it? And how do we do it? How we do it is actually the methods part. So, as far as what is psychology, it's basically the science of or study of behaviors that are overt and mental processes that are covert. And really what that means, if you think about what overt and covert mean, overt, the way I try to think of these is with overt, think of the O, and covert, think of the C. So, and I'll tell you what I mean by that here in a second. So for overt, laughing, crying, fighting, interacting with others, think about the fact that you can see those, right? So overt behaviors would be open, out there, observable. Those are all O words. So that might help you remember overt means out there, open, observable. Covert, on the other hand, would be thinking, memory, language, perception, all of these other things here where it's more covered or concealed. It's not like we can actually see it. Like maybe for happiness, we think happiness, we know somebody's happy if they're laughing. Well, sometimes we laugh when we're nervous too. So we don't really know. So what we are kind of seeing doesn't always match what is on the inside. And so that's one of the things that we need to think about, is that it's very difficult to measure those covert behaviors because thinking is a behavior, and it is very difficult to measure anything that's on the inside of the mind. So what we do in research then is we try to take those covert behaviors and we try to turn them into overt things that we can measure. So one example of that would be memory. So how do we know that people remember things? We can't really go into their brain to see, but we can maybe give them a test, give them a list of words, and see how many they remember. And so them recalling is that overt type thing that we can measure. It's open, observable, out there. But we are doing that to measure memory, which is that covert, which again, covert, think of covered, concealed, so it's more hidden. Okay, so I hope that kind of helps keep those two straight. All right, so why do we do psychology? You know, in psychology, there's so much research that's being done. So why? One of the things is we want to be able to describe how people behave. Because if somebody's doing something, first we have to notice it, and we have to be able to describe what it was that we saw. What was the actual behavior? So if we can describe it, then we can find out maybe what was the cause of that behavior. So in psychology, we want to understand what the cause of the behavior was. Once we understand what that cause is, then we can predict behavior. And once we can predict behavior, that's when we can influence the behavior or modify it. And then once we have that, that's when we know we can enhance life. So an example I tend to give is a cookie jar example. So let's say a child goes out to the kitchen and tries to get a cookie. And the parent doesn't really want them to, but they notice it's always like an hour before dinner. So you know the child is hungry, or the parent knows that the child is hungry. So what they do then is they can describe, okay, this child is going out to the kitchen to get a cookie every night. That's describing the behavior. Understanding when it's dinner time, the child is obviously hungry. So then we can understand that maybe that hunger is the cause of the behavior of going to get the cookie. And because we now know that, we can predict well, tomorrow night we're going to have dinner, and the child is going to go out and try to get a cookie. So we can then step in and try to influence that behavior by telling the child, instead of you eating a cookie before dinner, because that might actually ruin your appetite for the healthy stuff, how about let's wait? And if you wait until after dinner, I'll give you 2 cookies. Right? So in a way, we are using our understanding and predicting of the behavior to influence a better behavior, right? And that is meant to enhance life. And so this is basically why we do psychology. When it comes all down to it, we want to enhance life, but we can't really do that without all of the steps that are above that. All right, what kind of questions do we ask in psychology? The main one is critical thinking. So you can ask yes, no questions, but they're kind of boring if you think about it. Because, again, if I were to ask you, does sleep affect memory? Well, you'd probably say yes, and that's it. It doesn't go anywhere from there, so it's kind of boring. But if you think, how does sleep affect memory? So much more to discuss there, right? So that's a critical thinking question. What about what kind of sleep affects memory? That, again, would be so much more interesting than a yes-no question. But critical thinking also kind of digs in a lot of different ways. So some examples of that. If you hear a claim, you want to know, what does that claim actually mean? What does it imply for me? What does it imply for my family, for my students, for the world in general? What does it imply we do with that information? Even though there's a claim out there, is there an easier answer for it? Like if you think one thing is the cause of something, and that's your claim, is there another answer that is simpler or maybe just different, right? And even though that looks like a yes-no question, the basic thing is, what kind of answers are there that could be simpler or that could be an alternate explanation? That's the critical thinking part. The other thing is, how are the claims tested? So if you hear a claim about something and you really think about it, it's like, how did they establish that claim? Did they ask just a couple people? Was it a survey? Was it a research study where they had a huge sample, where they had a control group and an experimental group, where the control group and experimental group were exactly the same in almost every way, except for the one thing that they were testing? That would be more stringent than just asking somebody to fill out a survey. And then, how good is the evidence? How much does it actually support the claim? And so these are just examples of what I mean by really digging in and asking critical thinking questions. So that's what we do in psychology. All right. Violence in the media I have here as just a reminder, as if we think about what the claim is about that. So the claim would say that maybe violence in the media tends to influence aggressive or violent behavior or thoughts or things like that. So we have to ask, what does that mean? What does that imply? And so it might mean that we should maybe not watch as much violence, right? Or maybe, as far as if there's a simpler or alternate explanation, maybe we go towards the violence because we're interested in it, right? I mean, some people actually like scary movies or horror movies, some don't. That could just be something that's in them, that maybe they're driven to want to see it. So it might not be that the violence is the cause, or the media is the cause of the violence. It could be that somebody is just more drawn to that because that's kind of who they are, right? And another thing is, how are the claims tested? So a lot of times when we're talking about violence in the media, we're talking about kids. And it's not always the same answers if you ask the same question or you test it with adults. And so we also have to ask about how good is the evidence? Who does the evidence apply to? So lots of things that we can ask here. So how to ask good questions. And you'll need this for your annotated bibliography and your finals project. So how to ask good questions. First, they need to be thoughtful. So really think about the question. Again, not yes, no. Ask things like, if there's a claim out there, don't just assume it. Challenge it. Look at the literature out there. And when I say literature, I mean research studies. So look at the research studies and see, is everybody saying the same thing, or is one study saying one thing and another study is contradicting that? Challenge that assumption by looking into it and finding out, what does the research actually say? And in doing that, you're also asking for explanations or clarifications. You can also ask for support. And I also say justification. Not proof, though. And I usually talk about this in class, but we don't usually prove anything in psychology research. We do find support for hypotheses or theories, or we maybe fail to find support or evidence. But think about the fact that every single thing that's happened in your life has made you who you are at this very moment. And that's different from everybody else. So even though a theory might say what we see typically, that doesn't mean it applies to everybody. So we usually don't say proof. We just use the word support. So ask for what that support is. You can also try to find an unusual point of view, maybe a way of looking at something that nobody's looked at before. So to do that, you identify the puzzles or the mysteries. And you can do that as you're looking in the previous research. Maybe they're all addressing the research in the same exact way. But then you think, wait a minute, they're not thinking of this what-if scenario. And so that could be another thing that needs to be looked into. And so pose those problems, pose those what-if and why questions. That's really digging in. You also want to wonder about the practical applications for the topic. So in doing all of these thoughtful questions and doing research and stuff, you want to know what's the end result? What do we do with the results if we get the answer to our question? So basically there's a word for that. It's called implications. What do the practical implications or applications, either way is the right way to say it. Let's go back to the violence in the media example. If we say that when children watch violent things, they tend to have more violent type thoughts or behaviors, if that is actually a claim and it's well supported, where do we go from there? The practical application or the implication, what the results imply that we do, then would maybe be limit how much they watch it or are exposed to it. So don't just ask the question, try to think of, why are you asking that and what are we going to do with that if you get the answer for it? This will also help you with your annotated bibliography, because you're going to be bringing up not just the topic and what your question is, but the relevance to psychology. That relevance to psychology section, when you see the model, you'll see what I mean by that. But when you do the relevance to psychology, why is it so important that that question get answered? What can psychology as a field, or what can psychologists do with that answer? And so that's what you want to put in that relevance section. All right, when to do psychology? Easy, always. You always can do psychology, because really what happens after you get a research study and you get some answers, there's always why, what if, right? So there's always going to be some other thing to build on. So we will do psychology always until there aren't any whys left. And if you're truly inquisitive, there's always going to be a why or what if. All right, so how do we typically do it? This is where we get into the actual research methods part. So first thinking, how do we typically look for answers? Well, usually if we have a question, first thing we tend to do is go to Google. That might not be the best solution. It's a good start though. It can help you get terms to look for in the research. It could give you general definitions to consider, things like that. So a lot of times we do that, but we also might go to family and friends because we trust them. We might also think, well, what are our beliefs? What are our religious beliefs? What would they say about answering that question? Internet, like Google. What about music and literature? Sometimes we actually do look for that to find out answers about ourselves or just the world, right? If you think about all the music and literature out there that have messages, and if it's messages we resonate with, then we could actually use those as, helping us to determine some kind of an answer or generating part of an answer to your question. But some of these can have bias in them. Another thing that I want to bring up is intuition or common sense. Well, intuition and common sense, of course we want to have that, but it's not always the best way to answer a question. So one of the examples I like using is about self-regulation. And self-regulation, the SRL stands for self-regulated learning. If I said self-regulation means that you are learning how to plan things, you have goals, you want to plan how to get to that goal. You're going to monitor your progress in trying to reach that goal. And then if your strategies to reach that goal aren't working, you're monitoring so that you can adjust the strategies as needed. So that's kind of a little snippet of what self-regulation looks like. So that's actually been shown in multiple research studies for years that it helps students with their learning. And so that's usually like from first grade all the way through college. That's what a lot of the literature says. So when I was getting my doctorate, I wanted to find out, does that actually apply to preschool children? Because that was one age group that I didn't see as much research on. And I was specifically interested in Head Start children. And if you're not familiar with what Head Start is, that is a preschool that is meant for children that come from families that are disadvantaged, usually low income. Usually the criteria is they need to be at the poverty line or below. That's one of the criteria for actually getting into the program. But it's supposed to give them a head start. So make it so that when they go into kindergarten or first grade, they're actually at the same level as everybody else. So they don't fall into that same risk category of struggling in school. So that's what the program was for. So if self-regulation actually helps with preschool, then that would be a good thing. So that's what I wanted to find out. And so what I usually tell in my classes is when I did my research, I found out that it didn't help. And so I usually ask students, why? Why do you think that didn't help? And so some students say, oh, well, it's because they're too young. That they're not at a place where they can do any planning. Or maybe they don't know how to monitor things. They're too young to have strategies. Things like that. And then I get to debrief the class. Because those examples that I just gave you that are typical responses that I get in the classroom when I ask that question, I can then tell you the true results of my study were that the self-regulation skills that preschool children naturally have was highly predictive of them doing well. And so why then, what was happening when people were trying to give me examples on why it doesn't work. What it really means is that they were trying to make sense of information that they were given. And that's one of the things about intuition, is we try to make sense of information that we're given. So it's using our common sense after the fact, even if the information that we get is wrong. So when I said self-regulation skills don't help preschool children, if I gave that information and it's wrong information, you're still going to try to make sense of it. So that's why intuition is something that we should not really rely on. Right? You can in some instances, but it's not foolproof. All right, so what do we do then? How do we get answers? How about scientifically? So we come up with a common approach with certain principles. And that's where most people in younger grades learn about something called the scientific method. And so that's basically what we're going to go over. You've probably learned this in 4 steps, 5 steps, 6 steps, depending on who's teaching it. The steps are usually the same. But how it's taught is maybe a little bit different. You know, some people combine some of these into, like defining a problem. They would say, well, you have to see something and then figure out what the problem is and say that that's one step. I'm saying it as 2 totally separate steps. Because you have to really notice that something's happening. If you don't notice it, then nothing happens. You have to notice it. We'll also talk about that when we get to the memory chapter. So you have to notice that something happens. And then you have to decide, is there a problem with this? Or maybe there is a problem. And so you come up with a question, like why did that happen? And so in research, then you propose what the answer is. What do you predict is the answer? That prediction is your hypothesis. Once you have that hypothesis, in order to find out if it's got support, you have to test it. So you have to go and gather data and then analyze those data. And then if the results of that data support your hypothesis, that's going to help to build a theory. And then when you build a theory, then you can publish the results, get it out there so other people understand what's going on. And then they can build on the theory by going through what you have for your results and seeing, well, if I do this study, am I going to get the same results? Or, okay, I want to do this study the same exact way, but I'm going to see if I can tweak this one thing and see if I still get the same results. So it's kind of like your study is a building block for the next one. All right, as far as what a theory is, just as clarification, a theory is a system of ideas designed to interrelate concepts and facts in a way that summarizes existing data and predicts future observations. So basically what that means is that a theory is taking all of the available information and putting it together so that we can predict what's going to happen. Because earlier when I said we want to be able to predict behaviors, because that's when we can influence the behaviors to modify and enhance life, which is the major goal of psychology. Alright, so as far as what makes a good theory, well, it has to be based on facts and observations, right? It has to be testable. So if you have a hypothesis, it needs to be something where it's realistic for us to be able to test it and get good data, good usable data, right? Predictions are also usually supported by the findings, but because it's also testable, it means that maybe you don't get the support, right? So a theory in general is something where you can find support or fail to find support. So good theory then would then have that support. It also should conform to the law of parsimony. Now the word parsimony means simple. And so if we have 2 different research studies and they both have the same theory, and one is this really complicated detailed theory, And the other one is just a simple theory, or simpler theory. But it explains that phenomenon just as well. We're going to go with that one. Because why put all the extra details in when we can say this is the main part of it? This is really what's predicting it. So we don't actually have to have all of those other details. Okay, so for law of parsimony, that's another thing that makes a good theory. So when going back through the scientific process and just thinking about an example. An initial observation, let's say that somebody was bullied. So like we're at maybe a 4th grade playground. And we're sitting there on the bench and we're watching all the kids play. And then we notice, this was our initial observation, we notice that somebody's getting bullied. And no one's stepping in. No one's stepping in to help. So that's our observation. So we have to then define what's the problem with that. Well, the problem is, why did no one help? There's got to be something about that. Because obviously nobody should be bullied. But if that's the case and we all know it, then why did nobody step in? So that's our research question. So we have to first think, there's probably a lot of reasons why nobody stepped in. But let's say we want to at least test one thing. Maybe we think that the reason that nobody stepped in is there were so many people around, they thought somebody else was going to step in. So this is a theory known as diffusion of responsibility. It means that with so many bystanders around, people think that, okay, somebody else is going to take care of it, so it's not really my responsibility. So it diffuses the responsibility of the individual because they think somebody else is going to take care of it. So if that's why we think nobody helped, we need to test that somehow. So what we can do then is we can create some kind of a bullying situation. And I say controlled because you make it a mock situation. So nobody's really getting hurt. But then you can manipulate the perceived amount of bystanders. I say perceived because you might have some people that are in on it. So you have a lot of people present at one point, and then you do the bullying situation and see if somebody helps. And then you wait and do the situation again when hardly anybody is around. Right? And then you measure the helping and see when the helping happens more. If it's when more people are there or when less people are there. Or it doesn't matter how many people are there. As far as when I say on the slide there about measure helping and being specific, help means a whole bunch of different things. So in research, we have to operationally define that. So what that means is, how does it operate in our study? So maybe helping means stepping in and actually stopping the bullying. That could mean pushing the bully away. It could mean just talking to them during the situation. It could be helping could mean go get somebody, right? If we're on a playground, maybe go get the principal, maybe go get a teacher. It could also be maybe calling 911, right? That would depend on how bad the bullying is. But still, how we define helping and how we're going to measure it need to be very specific in our study. But so let's say we do that. We test the hypothesis and we find that when helping was not very prevalent, it's because there's more people around. Or we can say it the other way, that when there weren't very many people around, the helping actually increased. So either way, we're seeing that we have support for the hypothesis. So that means we're kind of building the theory. So the summary here would just say the amount of people that are present will affect the likelihood of somebody stepping in to intervene in a bullying situation. Okay, that doesn't mean it's the only answer, but that's the support so far for the bystander effect or diffusion of responsibility. They're called the same thing. So then we want to publish that. You can publish it in journals, you can publish it in papers, You can do poster sessions, you can do presentations. So somehow get it out there so that other researchers know what you found and they can build on that. All right, so as far as discussing what other reasons you can think of why no one helped, so again, diffusion of responsibility is not the only thing. So maybe the person didn't really know what to do, right? It's like they see the situation and they're not sure how to help, so they may not step in because of that. They might not step in because maybe they know what to do, but they don't think they're going to be effective in doing it. And that's called self-efficacy, which we'll go over later in the semester. It could also be that maybe they're afraid of getting hurt. So they're afraid of their own safety, right? And so there's so many other reasons that we can think of. And those are all individual studies. Okay, so as far as another scenario to consider, I'm going to post this on Canvas, separate from the PowerPoint. But basically, it's a what would you do scenario. So you can think, watch the scenario, and see why they are saying that nobody's helping. And then you can figure out or come up with ways that you think are reasons why nobody's helping. Something else I think you could do with this when you watch the video is there are some people that do step in. So you could also hypothesize, why did they step in when nobody else did? That's another really wonderful question to ask there. So not why does nobody step in, but why do some people step in? All right, so the proposing the hypothesis and testing the hypothesis, that's part of what I want to go over next, by going over how do we study. As far as the discussion, since I'm doing this as a PowerPoint on Canvas, there's not anything to turn in for points for this. So the way that we can do research, there's a lot of different methods out there. The only three I'm going to go over is descriptive, correlational, and experimental. So descriptive is exactly what it sounds like. You're describing, so you're just recording events. Correlations are looking for some association or relationship between events or variables that you're interested in. Experimental is when you really want to find out the cause of some kind of outcome. So you're specifically looking for cause effect. And so to go in more in depth on that, let's start with descriptive. With descriptive, it's also called observational, because really what you're doing is you're just watching and you describe. What are you seeing? So again, like let's say you went out to the playground and you're not going out there with a hypothesis. You're not going out there with a specific question other than maybe what are the behaviors on a playground? So you go out and observe and you describe. What are you seeing? All right, other examples of what descriptive observational would be like a case study. In a case study, you're not manipulating anything. You're just getting as much information as you can about that case and just explaining it. You can also interview people. You can survey them. You can just watch and write down what you see. Right? So all of these are descriptional. So they don't really give you that cause-effect thing that we usually want in research. But it is kind of like that building block that if you have the descriptive observational information, you can then build correlation studies or experimental studies off of that. All right, but the main thing to know that when we're doing descriptive observational, there's no manipulation or interference. Because we are not manipulating variables, that's one of the reasons why we cannot have cause-effect claims here. So, benefit, why do we do it? Again, it is a wealth of information. Because when you're just noting everything, describing everything, it's a wealth of information. And again, you can build studies off of that. Downside is we can have observer effect. We can also have observer bias. So what that means, observer effect, there's a lot of names for that. Reactance, reactivity, guinea pig effect, Hawthorne effect. But basically, observer effect means if somebody thinks they're being watched or observed, they're probably going to act different. And if you think about it, if you're home and let's say you like to sing, so you grab your hairbrush and you turn up the music and you start singing and dancing around your house because nobody's around. As soon as you know somebody comes into the house, most of you are going to change what you're doing. You're either going to stop totally, or you might keep going because you just enjoy it and you really don't care that they just came home. But the intensity is still going to be somewhat different, right? Sometimes it's going to be less because you don't want to be that intense, singing and dancing around them. Or maybe just the fact that they show up is like, ooh, I have somebody to perform for now. And so it might actually bring that up another level. But either way, the presence of somebody can affect behavior. And so you might not be getting the true response or the true behavior because of the observer effect. Observer bias is mainly if you are the only one observing, your bias can creep in with how you're actually describing things. And so usually if you're going to do a descriptive observational, you want other observers and you want to agree with what you're seeing and how you are measuring things. Or not measuring, but how you're describing things, right? So any way to keep that bias out of there so that you can be more objective. So for correlational research, again, that is looking for a relationship or association between variables that you're interested in. So I like using the examples of studying in grades because you would think that if people study more, maybe their grades are going to be higher. So we can look at those two things, like how much does somebody study and what are their grades? And we can see if there's some kind of a relationship. So the other example I like to look at is partying and grades. Because you can maybe guess or hypothesize that if you're partying too much, maybe your grades go down, right? And so you want to find out, is there a relationship with partying and grades? So let's look at that. When we're doing a correlation, we're going to look at the fact that there's either a positive or a negative correlation. Positive and negative don't mean good and bad. All that really means is what are the directions that the variables are going. They could both change in the same direction. And the sound you just heard in the background was my dog. So, again, positive and negative don't mean good and bad. It just means that it's the direction that the variables are changing. So if both of the variables you are looking at are going in the same direction, like as one increases, so does the other, that's called a positive correlation because they're kind of going together. If as one decreases, the other one also decreases, that's still called a positive correlation because they're going in the same direction. If you happen to have a negative correlation, it means that they're going in opposite directions. So negative doesn't mean bad. It just means they're going in opposite directions. One example is maybe the more somebody exercises, the lower their weight goes, right? So that's not a negative. I mean, it's not a bad thing. So negative wouldn't mean bad in that case. Maybe it's a good thing, right? So somebody's increasing their health because the more they exercise, the lower their weight is, right? So if we were to look at the partying in grades and studying in grades, let's say I gathered all my data and I plotted it for studying in grades. And this is what I notice is that there's a line that is going up towards the right. And the dots are really close to the line. First, in a correlation, you wouldn't necessarily have a line in there. That's a different statistic called regression. And you put that best fit line in there. Usually with a correlation, you're just going to have something called a scatter plot, which would have everybody's data point, and that's it, right? So you might have like 100 dots all within the graph, but usually not a line. So when the dots are really close to the line like this, it means it's a pretty strong relationship. But if you notice that as maybe studying increases, grades also increase, that's positive, right? If you also say as studying decreases, grades also decrease, you would still get the same line, right? Or the same pattern of dots. And so that's a positive correlation. The negative correlation, again, whether you say that as partying increases, grades decrease, you could also say as partying decreases, grades increase. Either way, they're going in opposite directions, but if you were to plot all of the data, you're going to get something that looks like this. It's going to be a downward sloping line or a pattern of dots. And the way that I drew, or the way that this looks here, is that the dots again are very close to making a line. So that indicates a very strong correlation. This one right here is no correlation because the dots are just all over the place, right? And so this is where the values come in that we need to know. Correlations range from -1 to +1 or anything in between. You're never going to have something over a +1. You're never going to have anything less than a -1. So you can almost think about the 1 as being 100%. You can't have more than 100%. It's either all there or it's not. So when you think of a number line, though, with correlations, you have a +1 on one side and -1 on the other side. The very middle is 0. So as your value travels towards the 0, it's getting weaker and weaker and weaker. When you get to 0, it means no correlation. There's no relationship. Extremely weak or non-existent. The more you travel towards 1, whether it's positive or negative, doesn't matter. As you're traveling towards 1, it gets stronger and stronger and stronger. Okay, so when you're looking at the values, do not think of whether it's positive or negative. Just think of what the value is. The closer to 1, the stronger. The closer to 0, the weaker. So based on that, if I were to present these to you, if you think, what is the weakest out of those? And I wanted to give you a few seconds there to think about it. So the weakest is actually -0.96, because the negative doesn't matter. That is closest to 1 out of all of those values. It just happens to be negative. So the negative tells us that it's a very, very, very strong relationship in that as one thing is increasing, the other one's decreasing. Right? So the weakest out of all of these values is 0.22. And so again, the positive part doesn't matter. It could be -0.22. So the 0.22 is the closest one to 0. So it's the closest to being no relationship. The positive just means as one variable is increasing, so is the other one. Or as one variable is decreasing, so is the other one. All right, so what are the benefits of this? First of all, correlations help because you can predict behaviors. So going with the scenarios, I can predict that if students study or study more, they're probably going to end up with overall average grades. I mean, not average, higher grades, right? Or the grades will increase. So that is the prediction. So basically, predicting is good. It's not a cause-effect thing, but it is a predict, right? So it just means that it's related somehow. It's also better to do correlation when experiments are not ethical. The example I usually give in class is I will point to 3 different females in the class and say, okay, I want you, number 1, to smoke a pack of cigarettes a day. And then I want the second person to smoke 2 packs a day. And then I want the third person to smoke 3 packs a day. And what I'm interested in is all of them are pregnant, and I want to know how much of your baby's going to weigh when they're born. First of all, that is so not ethical. And so something that would be more ethical would to maybe be a correlation and find out, usually what's said in class, people usually say, well, find people that are already smoking rather than telling them how much to smoke, and then find out how much their babies weigh when they're born. While that is more ethical than the first example I gave, that's still not ethical, because then you're telling pregnant women to continue smoking. Or not telling them to, but saying, oh yeah, it's okay. We'll just see what happens at the end. So the most ethical thing is find people who have already had babies. Find out, did you smoke while you were pregnant? If so, how much? And then, how much did your baby weigh when they were born? That's correlational. So that is better to do because it's not ethical to manipulate the smoking part while somebody's pregnant. But the downside of doing this is, regardless of whether you can predict behaviors or it's more ethical in some cases, you have to be really cautious about the cause-effect claim. So the reason this is in red is because correlation does not mean causation. Okay? Correlation does not mean cause-effect. Right? Why? So there's different reasons why we cannot make the claim, even if the correlation is really high. So if I gave you a value of 0.98 or 0.95, something like that, that's extremely close to 1. So that is so strong that it's very tempting to say, oh, well, that means this variable causes that one. No, it doesn't. We cannot make that claim. All right, so here's a couple reasons why. One is we might not know the actual direction of the relationship. So like with the penguins here, it says, do you think all these film crews brought on global warming, or did global warming bring on all the film crews? So we don't know which one came first. And so I'll give you the example of the partying and grades. Yeah, I mean, we can say that maybe we have a really strong correlation in that if we see a lot of partying, we're also seeing lower grades. But we can't really say partying causes lower grades, because it may just be that if you think about when you get low grades, that doesn't feel good, right? So if it doesn't feel good and you don't like not feeling good, what are you going to do? You're probably going to do something that'll make you feel better. Maybe that's going out to a party. So because we don't know if A is causing B or B is causing A, we cannot make that cause-effect claim. The other example is the fact that a lot of times there's another variable in there that could be causing both sides. So an example that is very common to use is the fact that ice cream sales and crime, they are extremely highly correlated in the summertime. But can I say that crime causes ice cream sales? Or can I say that ice cream sales causes crime? No, I can't. Because there's possibly another variable that's causing both the ice cream sales and the crime. And so usually that could be something like heat, right? So maybe because it's summer and it's hot, people want more ice cream. And then because it's summer and it's hot, maybe that is just raising the aggression levels in people. Or the crime because more people are out, right? Because when it's colder, maybe more people stay in. So, I mean, there's a lot of different variables that could be there. But this is why we cannot do that cause-effect claim, are these main 2 reasons here. So, okay, so I'm going to skip by this because that's the big ideas. The basic thing is if you want a cause-effect claim, you need to do an experiment. And that means you need to be able to manipulate something, right? And what I mean by that is when you have experimental research, the researcher actually has control of a specific variable, whatever variable they're interested in. So let's go with this study and grades. If I want to do an experiment, I can say, okay, you study for 2 hours, you study for 4 hours, and then this other person is not going to study at all. So I'm manipulating that. And if all of the participants are pretty much the same, except for that, that means I'm manipulating how much they study. And because that's the only real difference between all three groups, if I see that there is a difference in their grades, that's when I can say, ooh, okay, that's indicating then that the amount of studying does cause the grades. All right, studying strategies is another one that I tend to use. But I will leave that just because I just talked about just studying and grades. But sometimes the actual strategy matters. Okay, so usually in experiments then, we have an experimental group and a control group. Most people have heard of these. So experimental group is the person that gets the treatment. Control group, not person, people. So experimental group are the participants that get the treatment that you're interested in, that you think is going to make a difference. The control group is who you're using to compare with. Sometimes they get nothing, like they don't get any treatment at all, or maybe they just might get a different treatment. But either way, you're using that as a control, something to compare with the experimental group. We will have variables, right? So an independent variable and a dependent variable. The independent variable is the one that you manipulate. So my studying example, we would be manipulating that because then we want to see the outcome on grades. So the outcome is that dependent variable. Now, there's a sentence that I share, especially in my general psych class and my research methods class. And my stats class, I guess. If you want to keep these two separate, like understand the difference, think about this sentence. The dependent variable depends on the independent level of the independent variable. So I'll say that one more time. The dependent variable depends on the independent level of the independent variable. So if I use the studying as an example to replace that in the sentence, then I can say the grades, which are the outcome, the grades depend on the level of studying. Whether it was no studying, short studying, long studying. Okay? So again, grades depend on the level of studying. All right. But now these are not the only two variables in research. There's something else we need to be aware of. There are extra variables out there that we might need to control in research. Because maybe it's called extraneous, but think of the word extra. It's an extra variable that could have an effect on the outcome, but you're not actually interested in studying that. So you want to control for that. All right, so basically you can say that the extraneous variables are the unwanted or unintended variables. So that's why you want to control for it, so that you know that the groups are as equal as possible, except for that independent variable. So then at the end, if your independent variable is showing to influence the results, or the dependent variable, then we can actually make that causal assumption. We can then say, yes, I can say that the amount of studying you do is going to cause your grades to differ, in that when you study for 2 hours versus 4 hours, there's a significant difference between those two, where your grades will be significantly higher if you study for 4 hours rather than 2 hours. That is that cause-effect claim. All right, so benefit. First of all, just making that cause-effect claim is a huge benefit of research. I mean, that's one of the reasons why we really want to do this. We want to find the cause so that we can then enhance life, right? We can modify behaviors to enhance life. So the causal assumption is huge here. Downside, it's not easy to put a research study together. If any of you ever end up in my research methods class, we'll go over so many reasons why research is very detailed, and there's so much more to it than people think. It's also very difficult to design because you also have to consider not just how you're going to study, but you also want to keep your participants safe, right? You don't want to harm them. So you want to consider ethics. So as far as what are ethics? Well, if you think about what ethics or morals are, it's something we care about in research because, again, we don't want to hurt people. We want to know that we're doing the right thing for them. Right? So what do we do about that then? Your textbook actually has some guidelines on how do we carry out a research study that is ethical. But there are some guidelines that I wanted to go over. There's a place that's called the IRB, or Institutional Review Board. These are the people that get your proposed research, and they will approve it as being ethical, or they will say, you need to work on this part. This is not quite ethical. And so you would maybe need to edit and then resubmit that proposal. But you don't want to do the research until it has gone through an ethics committee. All right, unless there's absolutely no risk. But usually the IRB is the one that's going to determine whether there's no risk. So some of the guidelines that they have for making sure that participants are safe are that all participants have the right to withdraw from a study without penalty. So that means if you are collecting data, and let's say somebody says, sure, I'll be in your study. And let's say you tell them, I'm going to pay you for every I'm going to pay you $5 for every hour that you're in my study without penalty. If they want to drop out, it doesn't matter if they drop out right at the very beginning or you have collected all of the data except for the very last part and they drop out. You're still supposed to pay them, right? You could put it in there as an ethical thing that you'll pay them after completion of gathering all data. So that way you're being as honest with them as possible. It's like you want the data, but you also want it complete. And so you can reward them for finishing the study. However, you have to understand that they do have the right to withdraw at any time. So in research, you just need to be okay with that. Because they are volunteering to be part of your study. So, or not always volunteering if you're paying them, but they're agreeing to be in your study, right? So you can't force them. So they have the right to withdraw from a study anytime. All right, they also have the right to privacy, and that extends to the level that even though, like if you think about children in studies, even if parents give permission for a child to be in a study, usually the child's data are going to be confidential. Okay? If the parents are allowed to get the information, it's usually just information. You're not doing evaluations as a researcher. You're not giving advice. You are just giving what the data show. Okay? So like if you were to have your child go into research, or go into a research study, and they're doing IQ, maybe you're curious, what was their IQ score? And so the researcher can tell you, okay, we did an IQ test. This is what the IQ was. And so they're saying what the data show. They should not evaluate it by saying, oh, this is a really high IQ. Maybe you should get them in gifted classes. Or, you know what, this is really low. Maybe you should get them some tutoring. You can't really do that, right? So you let them know what the data show. That's it. Because everything else is supposed to be confidential. All right, regardless of the nature of the study, any study that's using children as participants, it needs to be minimal risk. And when you go through the ethics committee, it usually takes longer when you're dealing with children, because most of the time we don't know the long-term effects of things in children until we've studied it for a long enough time. And so because of that, the ethics committee is usually a little more protective over children. Because adults, we can bounce back, we can reason with them. They do have more, I don't want to say that they have more say in whether they stop an experiment, but they understand that more than children do. All right. Also, the rights of the child, even infants, always supersede the rights of the investigator. So I think that one is self-explanatory. So always put your participants first. The other thing, too, is that let's say you put a study together and you bring it to the IRB and they approve it. If you change anything in there, like maybe you're changing the age range that you're looking at, or maybe you're changing the way you're defining a variable or how you're measuring a variable, you're supposed to do a revision, resubmit it so that the IRB can reapprove it. So you really don't want to make a lot of changes unless absolutely necessary, or just make it as thorough as possible before you submit it the first time. Okay, what about deception? Deception is actually used in research, but only when necessary. But think, when would deception really be necessary? So that was that wait time to let you think a little bit. But deception is usually used in research when, if the participants know what the deal is, that can change the results. So if you think about drug studies, if I was given some people a drug and the other one's a placebo, if I were to tell you you're taking a placebo, do you think that's going to work? Usually not, right? So they have to use deception in there. They have to basically say, okay, everybody's going to be taking this medication. Or they might say some people are taking placebos, some are taking the actual medication. But they're not going to tell you who, right? Because they want you thinking that you're taking the medication. So they're technically deceiving you. So it is only used when it is necessary. And if you use deception, you're also supposed to debrief them as quickly as possible at the end of the study. And so the debriefing basically says, this is what the true meaning of, or the true purpose of the study was. These were the results. And you make sure that the participants that were in your study leave your study the same or better than when they agreed to be a part of it. You don't want them worse off. So again, a deception and debriefing. Debriefing is very important to protect your participants. The other thing, if an experimental treatment is found to be a benefit, so maybe whatever you're doing, maybe you find studying does help, right? But you're not letting the control group study or study as much. They need to be able to also have access to that. So even if it's not during the study, immediately afterwards or as soon as possible afterwards, you want to know that the control group has access to that same benefit. All right, so those are just some things to consider with ethics. There's a whole bunch more. There's more in the book. And if you go into grad school or if you go into research, you will learn about so many other ethical issues that need to be considered. All right, this is also something that we would typically talk about in class. And research in the media, that is the commercial. So that is the Chesterfield's commercial. That is the discussion board online. So go ahead and make sure that you have your original post, which is responding to my prompt, and then make sure that you have those responses to your peers and try to get those in before the deadline. Okay, that's it. So that is it for chapters 1 and 2. So now you can actually finish your study guide notes, go in and do your chapter assessment. Your 1-minute notes, again, is a reflection of all your learning from the first module. And so do your 1-minute notes last, dig in, make it really thoughtful, and then we'll hit the memory chapter next time. So let me know if you have any questions.